OSHA Regulations 29 CFR 1910.333 tour states that electrical equipment must be de-energized before performing any work on it unless it can be done safely while energized. 29 CFR 1910.269 requires the employer to ensure that each cord used for temporary wiring is protected by an overcurrent protection device such as a circuit breaker or fuse. 29 CFR 1910.306 mandates that electric cords and cables must be inspected regularly and discarded if damaged. The NEC, or National Electrical Code, also provides guidelines. Article 400.7b specifies that temporary wiring shall be installed as described in Article 305 and shall not be used for more than 90 days. Article 305.2 ATW says that flexible cords shall not be used as a substitute for the fixed wiring of a structure. Article 400.22 states that electric cords and cables shall be secured to prevent them from becoming tripping hazards. Several additional considerations should be taken into account. Control panels and cords should be UL listed or otherwise tested to ensure they are safe for temporary testing. Grounding of the control panel and test equipment should be done properly to minimize the risk of electrical shock. Testers should wear appropriate personal protective equipment, or PPE, including insulated gloves, safety glasses, and non-conductive shoes. A qualified electrician should supervise temporary testing procedures to ensure safety. The test setup should be isolated from all energized circuits to prevent accidental contact. Warning signs should be posted in the testing area to alert others of the potential electrical hazard. Here is a safe procedure to follow. Firstly, de-energize the control panel. Secondly, lock out or tag out the disconnect. Thirdly, connect the temporary power cords to the control panel. Fourthly, inspect the cords for damage. Fifthly, secure the cords to prevent tripping hazards. Sixthly, ground the control panel and test equipment. Seventhly, put on your PPE. Eighthly, test the control panel under the supervision of a qualified electrician. Once testing is complete, de-energize the control panel and remove the temporary power cords. Let's elaborate on some of these points in more detail. Firstly, regarding OSHA regulations, understanding and adhering to these standards is crucial for maintaining a safe working environment and preventing electrical accidents. The requirement to de-energize equipment before working on it, unless it's demonstrably safe to work energized, forms the cornerstone of electrical safety practices. This minimizes the risk of electric shock and arc flash incidents. The rule about overcurrent protection for temporary wiring ensures that in the event of a fault, the circuit will be quickly de-energized, preventing fires and other hazards. Regular inspection and timely replacement of damaged cords are essential for preventing insulation breakdown and potential electrical shocks. Secondly, concerning the National Electrical Code, the NEC provides specific guidelines for temporary wiring installations to ensure they are safe and compliant. The time limitation on temporary wiring is in place because such installations are typically not as robust or well protected as permanent wiring. The prohibition against using flexible cords as a substitute for fixed wiring is to prevent overheating and fire hazards that can arise from undersized or improperly installed cords. Securing cords to prevent tripping hazards is a simple but effective measure to prevent accidents and injuries in the workplace. Thirdly, looking at additional considerations, using tested and approved equipment is paramount. UL listing or similar certifications indicate that the equipment has been evaluated for safety and performance by a recognized testing laboratory. Proper grounding is a critical safety measure that provides a low resistance path for fault currents, helping to trip circuit breakers or fuses and prevent electrical shock. PPE, including insulated gloves, safety glasses, and non-conductive shoes, provides a barrier of protection against electrical hazards. Supervision by a qualified electrician ensures that testing procedures are carried out correctly and safely. Isolation of the test setup from other energized circuits prevents accidental contact and potential electrical accidents. Clear and visible warning signs alert personnel to the presence of electrical hazards and the need to exercise caution. Fourthly, let's break down the safe testing procedure in greater detail. The energizing the control panel is the first and most important step in ensuring safety. This eliminates the risk of electric shock during the testing process. Lockout/tagout procedures involve placing a lock and tag on the disconnect switch to prevent it from being accidentally re-energized while work is in progress. Connecting temporary power cords requires careful attention to ensure proper connections and avoid loose or damaged wires. Inspecting the cords for damage before each use is essential for identifying potential hazards such as frayed insulation or exposed conductors. Securing the cords to prevent tripping hazards can be achieved by using cable ties, tape, or other methods to keep them out of walkways. Grounding the control panel and test equipment provides a path for fault currents to flow safely to ground, minimizing the risk of electric shock. Donning PPE provides an additional layer of protection against electrical hazards. Testing the control panel under the supervision of a qualified electrician ensures that the testing is performed correctly and safely, and that any potential problems are identified and addressed. Finally, once testing is complete, de-energizing the control panel and removing the temporary power cords completes the safe testing procedure. Some further discussion can be had regarding the types of personal protective equipment, or PPE, to use when working with 480-volt three-phase power. Firstly, insulated gloves. These are perhaps the most important piece of PPE for electrical work. They are rated by voltage and should be selected based on the maximum voltage you might encounter. For 480-volt systems, you will need gloves rated for at least 500 volts, but it is generally recommended to use gloves rated for higher voltages to provide an additional safety margin. Always inspect gloves for any signs of damage such as cuts, tears, or punctures before each use. Secondly, safety glasses or face shields are important for protecting your eyes and face from arc flash and flying debris. Arc flash can cause serious burns and blindness, so it is essential to wear appropriate eye and face protection. Choose safety glasses that meet ANSI's IT 7.1 standards for impact resistance. A face shield can provide additional protection for your face and neck. Thirdly, non-conductive shoes or boots are essential for preventing electric shock. Choose shoes with rubber soles that are designed for electrical work. Avoid shoes with metal parts, as these can conduct electricity. Fourthly, flame-resistant clothing or FR clothing. In situations where there is a risk of arc flash, it is important to wear FR clothing. FR clothing is designed to resist ignition and prevent burns. The level of protection required will depend on the potential arc flash hazard. Refer to NFPA 70E for guidance on selecting appropriate FR clothing. Fifthly, hearing protection. Electrical work can be noisy, especially when working with power tools or equipment. Wear earplugs or earmuffs to protect your hearing from damage. Sixthly, voltage-rated tools. When working on or near energized equipment, use tools that are rated for the voltage you are working with. Voltage-rated tools are designed to provide insulation and prevent electric shock. Inspect tools regularly for any signs of damage. Seventhly, insulated matting. Using insulated matting on the floor can provide an additional layer of protection against electric shock. Insulated matting is designed to provide a non-conductive surface for standing on while working on electrical equipment. It is important to ensure that all PPE is properly maintained and inspected regularly. Replace any PPE that is damaged or worn out. In addition to wearing appropriate PPE, it is also important to follow safe work practices when working with electrical equipment. These practices include energizing equipment before working on it, using lockout/tagout procedures, and maintaining a safe distance from energized parts. It is important to receive proper training on electrical safety before working with electrical equipment. Training should cover topics such as electrical hazards, safe work practices, and the use of PPE. Also, a point on grounding. Grounding is a critical safety measure in electrical systems. It provides a low-resistance path for fault currents to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock. In a grounded system, one of the conductors, typically the neutral, is intentionally connected to earth. This creates a reference point for the voltage in the system and helps to stabilize the voltage. Grounding also helps to reduce the risk of static electricity buildup, which can be a hazard in some environments. There are several different methods of grounding electrical systems. One common method is to use a grounding electrode, such as a ground rod or a metal water pipe, to connect the system to earth. The grounding electrode should be installed in accordance with the NEC. Another method of grounding is to use a grounding conductor, which is a wire that connects the system to a grounding point at the service entrance. The grounding conductor should be sized according to the NEC. In addition to grounding the system, it is also important to ground individual pieces of equipment. This can be done by connecting a grounding wire from the equipment to a grounding point, such as a metal enclosure or a grounding busbar. The grounding wire should be sized according to the NEC. It is important to regularly inspect grounding systems to ensure that they are in good condition. Check grounding connections for corrosion or damage, and make sure that grounding conductors are properly sized and installed. Poor grounding can increase the risk of electrical shock and equipment damage. A properly grounded electrical system is essential for safety. Grounding helps to prevent electrical shock, reduce the risk of fire, and protect equipment from damage. Make sure that your electrical system is properly grounded and that you follow safe work practices when working with electrical equipment. Another crucial aspect of ensuring safety during temporary testing of control panels is the implementation of a robust lockout/tagout procedure, commonly referred to as LOTO. Lockout/tagout is a safety procedure used to ensure that dangerous machines are properly shut off and not able to be started up again prior to the completion of maintenance or servicing work. It requires that hazardous energy sources be isolated and rendered inoperative before any employee begins work on the equipment. The procedure involves affixing a lock and a tag to the energy isolating device, such as a circuit breaker, to indicate that the equipment is not to be operated until the lock and tag are removed by the person who placed them. Key elements of a LOTO program include, firstly, a written LOTO procedure that clearly outlines the steps for isolating and locking out energy sources. This procedure should be specific to the equipment being worked on and should be readily available to all employees. Secondly, training for all employees who may be involved in LOTO procedures. Training should cover the purpose and function of the LOTO program, the steps for isolating and locking out energy sources, and the requirements for using locks and tags. Thirdly, identification of all energy sources that need to be controlled during maintenance or servicing. This includes electrical, mechanical, hydraulic, pneumatic, thermal, and other energy sources. Fourthly, use of appropriate lockout devices, such as locks, tags, and hasps. Lockout devices should be durable, standardized, and easily identifiable. Tags should clearly state that the equipment is not to be operated and should include the name of the person who applied the tag. Fifthly, verification that the energy source has been properly isolated and locked out before work begins. This can be done by testing the equipment to ensure that it is not energized or by visually inspecting the energy isolating device. Sixthly, coordination of LOTO procedures when multiple employees are working on the same equipment. This ensures that all employees are aware of the LOTO procedures and that no one is accidentally exposed to hazardous energy. Seventhly, periodic review and update of the LOTO program to ensure that it is effective and compliant with OSHA regulations. This review should include an assessment of the LOTO procedures, training, and equipment. When applying LOTO to the temporary testing of control panels, it is essential to identify all potential energy sources that could pose a hazard during testing. This includes the main power supply, as well as any auxiliary power sources or stored energy devices. The LOTO procedure should clearly outline the steps for isolating and locking out these energy sources before any testing is performed. Only authorized employees who have been properly trained in LOTO procedures should be allowed to perform lockout and tagout. It is also important to ensure that all employees who may be affected by the LOTO procedure are notified before it is implemented. During the testing process, it is crucial to maintain strict control over the locked out energy sources. The locks and tags should remain in place until all testing is completed and the equipment is ready to be returned to service. Once testing is complete, the authorized employee who applied the LOTO devices should remove them following the established LOTO procedure. The employee should also verify that all tools and equipment have been removed from the control panel before it is re-energized. Finally, it is important to document the load-tour procedure and to maintain records of all load-tour activities. This documentation should include the date and time of the load-tour, the names of the employees involved, the equipment that was locked out, and the steps that were taken to verify that the energy sources were properly isolated. By implementing a comprehensive load-tour program, employers can significantly reduce the risk of accidents and injuries during temporary testing of control panels.